Okay, so back to number 24. Part A wants to know what is the force experienced by the 4 microcoulomb charge. So I numbered them the way they were listed in the question. So I made the 4 my number 1. So the first step then in A is looking for FQ12, which will be KQ1Q2 over R squared, and FQ13, which will be KQ1Q3 over R squared. So K is 9 times 10 to the 9th. Newtons meters squared per coulomb squared. Q1 is the 4 times 10 to the negative 6 coulombs. Q2 is negative 6 times 10 to the negative 6 coulombs. And the R between them, now I didn't write in any distances. 3 right angle, base of the triangle. The distance between the 4 and the 8 is 75 centimeters. So this is 0.75 of a meter. And between the 6 and the 8 is 100. So it's, which is 1 meter. So it's a 3, 4, 5. So this is going to be 1.25 meters, right? 3 times 25, 4 times 25, 5 times 25. So this is 1.25 meters squared. And then this guy will be 9 times 10 to the 9th Newton meter squared per coulomb squared, 4 to the negative 6, and 8 to the negative 6 coulombs. And its R was, oops, sorry, where did it go? 0.75 squared. Okay, so this FQ12, I believe, works out to be 0.13824. 0.13824 newtons. And this one, 13, works out to be 0.512 newtons. So then what you have to do is you have to redraw number 1, and you have to say, okay, which way is number 3 acting on number 1? And the answer is, it's pushing it up. So this is going to be your 0.512 newtons going this way. And what is number 2 doing to number 1? It's going to be attracting it down at an angle like this. Now this angle will be this angle. This angle here will be this angle here, because they'll be alternate or opposite angles. So it's going to have an x component and a y component. So this is FQ12y, and this is FQ12x, and this was the 0.1, did I say it was? 13824, 13824 newtons. So y is going to be opposite, so 0.13824 newtons sine of, and this is a 3, 4, 5, so this is going to be 36.87 because it's the smaller side. So 36.87, and this one's going to be 0.13824 newtons, and it's the adjacent cos, again, of 36.87 degrees. So x is 0.11. No, okay, sorry, no, that's not what it is. Okay, so whatever you get there, oh yeah, it is, I was right, it is the x. So 0.110542 newtons, I think. And that's going to be your total in the x. So it's going to be your total in the x, because there's only one force acting in the x. Okay, but your total in the y, you're going to have to subtract them. So your total in the y will be your 0.512 newtons minus this 0.13824 newtons sine of 36.87. And so your total in the y ends up being 0.429 newtons. Okay? This guy is going east. This guy is going north. And so now you're going to draw it. So the one going east is tinier, 0.110542. The one going north is significantly bigger, 0.429 newtons. You're going to square them, add them together, and this will be FQ on number 1. So FQ on 1 ends up equaling 0.443 newtons. And the angle here at 14.454 degrees, and that will be CCW positive X. That is part A. Part B says, well, now imagine, where'd my red pen go? Now imagine there's a fourth corner. What is the electric field strength at this corner? So now to find that, we have to find the electric field from each of these 3 charges at that point. Okay? So, can't tell where my paper is. So for B, you're going to do E1 at 4, which will be KQ1 over R. So 9 to the 9th Newton meters squared per coulomb squared. And Q1 was 4 to the negative 6 coulombs. And the R is going to be the 1 meter squared. Okay, and then KQ2 at 4. So it's going to be 9 to the 9th Newton meters squared per coulomb squared, and Q2 was negative 6 to the negative 6, and its R is this distance, which is 0.75 squared, and then you're going to do E3 at 4, KQ3 over R squared. So 9 to the 9th Newton meters squared per coulomb squared times, that was 8 to the negative 6 over, and Q3 will be this diagonal, which strangely enough is also 1.25, just like the other diagonal was, squared. Okay, so you type these 3 in, and then you do, the first one is 36,000 newtons per coulomb. The second one is 46,080 newtons per coulomb. And the last one is 96,000 newtons per coulomb. Now, field is a vector. So now we have to look at this point and we say, what way are the fields going? So the 4 is positive, and field lines come out from a positive. I'll redraw it down below, but this is going to be E from 1. E2 is negative, and the field lines go into a negative. So E2 will be going down. And 3 is positive, so they go out from a positive, so this must be E3. And we're going to have to find its components. And this angle will be this angle, which will be, this is 0.75, so it'll also be 36.87. Okay, so redrawing that down here just so that we can work with it. So we had 1 going out this way. We had 2 going down this way. So this was E1, 36,000 newtons per coulomb. And this was 46,080 newtons per coulomb. And then this was 396. And so there's an E3X. And of course I labeled my E1 right in the way, and an E3Y. And this is 36.87. So Y is going to be sine. E3Y is going to be 96,000 newtons per coulomb, and that's going to be sine of 36.87.